All right, we're going to do related rates example 3. Leslie and Ben, sorry, it should say leave their house. This is what happens when you write too much stuff. Leslie and Ben leave their house in Pawnee, Indiana, obviously, and get in their cars. Leslie drives due south at 20 miles per hour, and Ben drives due east at 30 miles per hour. After 30 minutes, at what rate is the distance between them changing? Okay, so remember, this is a related rates problem, so we should use dread saw, right? The first thing we should do is draw a diagram with rates. So when you do problems that involve directions, you should make sure that your north is usually up. It's just easiest to make north up on your paper. So I always say never eat slimy worms. That's the way I always say it. Some people say never eat soggy waffles or never eat sour watermelon or whatever. I always, or news. It's not news. Sorry, that's not a word. Okay, so that's why you don't say news, because it would be wrong. So anyway, never eat slimy worms is what I use. So here's what we know, right? I have some house, right? And Leslie is going to leave and drive due south, right? So I'm going to call this side L for Leslie, right? And I'm going to call it a variable because it's changing, right? And Ben is going to drive due east. I'm going to call this B for Ben, right? I can assume safely that east and south make a 90-degree angle with each other, and I know that the distance between their two cars would be the hypotenuse of this right triangle, which I'm going to call D, right? So I know some other things, right? I know how fast Leslie is driving. I know that dl dt, right, dl dt, which is the rate of change of L, which is how I measured this length, right, dl dt, should be a 20 miles per hour. And it's positive because although she's driving south, it's not about which direction you're driving, it's about whether the length of the quantity you're measuring is getting longer. L is getting longer because Leslie's getting farther from home, so as Leslie gets farther from home, L gets longer, thus dl dt is positive. By the same argument, db dt, which is also positive, again, not so much because he's going east, but because he's driving away from home, so B is getting physically longer, db dt is 30 miles per hour because Ben's driving a little faster, right? So those are my diagram and my rates, right? So now I need an equation that relates L and B and D. And in this case, they are all variables because we don't know those quantities for any of these. Nobody's stationary. It's not like Leslie drove somewhere and parked. She's still driving. It's not like Ben drove somewhere and parked. He's still driving. And as long as they're driving, the distance between them is changing. So the equation I want to use is the same equation I used for the latter problem, which is Pythagorean Theorem. L squared plus B squared equals D squared, right? Then I need to derive with respect to time. So I'm going to get a 2L dL dt, right, because I'm deriving with respect to something that's not L, plus 2B dB dt equals 2D, and then, boy, there's a lot of D's, dd dt. That's a lot of D's, right? If you tried to show this to people that don't do any calc, they'd be like, that's a lot of letters for a math problem, right? Maybe you feel that way too. So anyway, if you want to divide the whole thing by 2, you can. It'd certainly make your life a little easier. Now let's make a list of the stuff I know, right? I know dl dt, right? I know db dt, right? I want dd dt, right? I want the rate at which the distance is changing. So really, it seems like the stuff I need to find are L and B and D, right? L and B and D. So now we can talk about when we get to that specific time, right? That substitute specific stuff. Now we can draw a diagram a little bit different. Now my diagram doesn't have to just have variables because now it's a snapshot of a moment. It's not a video, right? So at this moment, we are 30 minutes into this drive. Well, if Leslie is driving 20 miles an hour, then she has gone 10 miles in 30 minutes, right? I got that by saying, oh, 20 miles per hour times a half hour, because that's what 30 minutes is. And Ben has driven 15 miles because he was driving 30 miles an hour. And I can find this missing side by using Pythagorean Theorem. It's going to be the square root of 15 squared, right, which should be 225, right, and 10 squared, which should be 100, so it should be the square root of 325, right? It's not a nice, happy, super exciting number, and there's not much I can do with it. I can leave it as the square root of 325 if it's a non-calculator problem. I can also find the square root of 325 if it is a calculator problem, but here we are. So that's my D for now. So now when I go to plug in my stuff, and I'm going to erase my ridiculous long wordy problem that took up the entire space, right? It's why we don't write essay problems on whiteboards, man. All right, so cool. So if you want, you can go ahead and solve for dt ahead of time, right? So if I divide everybody by this 2d, I could actually just go ahead and cancel the 2's because I could factor a 2 out of everybody. And I'm going to get that dd dt is going to be L times dl dt, plus b times dB dt all over d, right? And that's fine. So if I plug in my numbers, L is a 10, right, times dL dt, which is a 20, plus b, which was a 15, times dB dt, which was a 30, all over the square root of 325, right? And if I don't have a calculator, that's fine, right? I'm going to leave my answer as something messy with a root, and that's okay. So I get a 200, right, on the top. And then here, this is a 15 times a 15 times a 2, right? That's what 15 times 30 is. 15 times 15 times 2. Or you could have done 15 times 3, which is 45, and then tacked on a 0. Either way, this is a 450, this is a 200, so you end up with a 650 over root 325. And D is measured in miles, right? And time is measured in hours, so I can just say miles per hour. Now, if it's a calculator section and you want to, you can go ahead and clean that up and make that into a decimal, and that's fine. You could do 650 divided by the square root of 325, and nobody's going to care. One of the nice things about calc, right, so this is approximately 36.055 or 6, depending on if you round or truncate miles per hour. What I will say is it makes a lot more sense if you do type it in for problems like this to check if your number is reasonable. If they'd been moving away at like 1,000,000 miles per hour, then maybe I'd be concerned I'd done something wrong. But 36.055 miles per hour makes a lot of sense because it's a combination of both of their speeds. So there you have it.